Hello everyone. This is going to be a cosecant graph that we're going to work with today. So we're going to work through our key information first, and then we'll talk about plotting the key points. So I'm going to start here by finding my period. This multiplier here is what we're going to use to help find that period. It's going to be 2 pi divided by 1/3. When we divide by a fraction, it's the same as multiplying times the reciprocal. So in this particular case, our period length is 3 pi. Our amplitude comes from the multiplied value times cosecant here. So our amplitude will be 3. Our vertical shift is this 3 here, so it will also be 3. And our phase shift will be -3 pi. That value is coming from inside our parentheses here. We take the opposite of what we see there to create our phase shift. So I'm going to go ahead and start labeling my key values here. Let's see. Yeah, this should work. So I'm going to use my 8-block method. I always like to use 8 blocks for a single period. The reason I like to do this is that it's very easy to break into quarters, right? And we know that at every quarter way through a period, where our function should always be at a minimum, a maximum, or along the midline. Before we get into that, let's just keep moving forward here with our setup. So I'm going to let 4 units to the left. Even though this is a little strange, our intervals are a little strange, this will be best for graphing. I'm going to let that point there be -3 pi. And then on the positive side, 4 blocks, I'm going to have +3 pi. So this distance here between the two marked horizontal axis points is a full period. Now I'm going to set up my vertical component here. You know what? Let's include a second period. Let's do 1, 2, 3, 4, 5, 6, 7, another 8 units here. That'll be 9 pi. I know that's 9 pi because our period is still 6 pi, 3 plus 6. Hey, we got it. It's 9. So now I'm going to set up my vertical component here. I know that my midline is going to be the same as my vertical shift. 2, 3. So we can go one block per unit here. We'll make this 3. And then we need to go up 3 as well. That's our amplitude. So 1, 2, 3. That'll get us to 6. So cosecant is directly related to, it is the reciprocal of the sine function. So what we're going to do here is and I'm just going to sketch in the midline here just so we can see it. And let's see. Oh, that should be sufficient. So I know with sine, sine always starts at the midpoint. So we're going to plug that point in here. We're going to plug in what essentially starts our period for this function. By the end of this period, we are going to be back to where we started. That's how we define a period. And then in the intervening intervals, which I did not label, and I'm going to go ahead and do now, halfway between 0 and 3 pi is 3 pi over 2, and that'll be the same on the negative side. So at -3 pi over 2, this is related to a positive sine function, so we should be at a maximum there. We should be back to the midline at 0, and then we should be down at a minimum at 3 pi over 2. So those are our key values. We can keep going here. Let's just mark these every 2. So again, midline to a maximum, to a midline, to a minimum. Notice here, I'm not really evaluating at any specific value. I'm using the setup of my horizontal and vertical axis to guide my work. Now, if this were a sine function, I would continue as we're doing here and connect our dots with a nice smooth curve. But we're not dealing with the sine function, we're dealing with its reciprocal. And what we need to do here is anywhere the sine function is equaling the midline, right? Where we would normally think about x-intercepts, but the midline is really what matters here. Those are going to become vertical asymptotes. So there's a vertical asymptote at negative 3 pi. There's a negative asymptote at 0. There is, sorry, a vertical asymptote, not a negative asymptote. A vertical asymptote at positive 3 pi at what is halfway between 3 pi and 9 pi, 6 pi total. That should be 6 pi. And then finally, we have an asymptote all the way out at 9 pi. So we're using the points we would normally use on the sine function, just we're not quite using them the same way. Those points where we're on the midline, those have become asymptotes, and then all of these other points are always going to be almost quadratic looking half curves here, right? We are always going to draw these arrows pointing away from the midline, right? So we should never cross the midline with secant or cosecant graphs. Right, obviously, this is a cosecant graph, but the process is identical when we're dealing with a secant graph. We would just plot the related points of cosine. So just as we would for sine and cosine, with a cosecant graph, we need to find our key values. We need to figure out where we start and where our period ends and plot our critical values. Our critical values are any place where we're at a maximum, a minimum, or on the midline. Those values where we're on the midline become vertical asymptotes. Maximum points, like you see here, become minimum points. Right? If they were a maximum on sine, they're now a minimum on cosecant. And if they were a minimum on the sine graph, they're actually a local maximum on the secant graph. Excuse me, cosecant graph. Stay tuned. Our third graph will involve a tangent or cotangent graph.